Hi everyone, welcome to CPO 240 Quality. We're on session 12, data collection. Now this would have come in handy a couple of weeks ago when we were initially thinking about the different projects that we were going to be doing for our quality, because it really does address the issue of data collection. And then of course we needed to make sure that you got all of your free 30-day trial for QI macros, so we had to kind of jump around. And for those of you who haven't done your project yet or are collecting data now, this will come in handy. So let's go over it. So for this lesson, we're going to identify the various types of data that you process technicians would actually possibly collect. We'll characterize it and then explain the concept of operational definition. I want to explain this here. Operational definition really is pretty key. It's kind of like, it's just really the key to your whole project, like what it is, how you define something, and what it is that you're going to collect the data about. So if you define it, you know what it is you're defining, and you really know the problem and defined it well, then you know how to collect the data to get what you want. And then we'll talk about characterizing the purpose of sampling, and then any time you possibly falsify records, what are the consequences involved. Demonstrating an analytical mindset, and then we want to emphasize the importance of accuracy and precision. So here's a data collection comic. You can read that, and then I'll give you a few seconds to read it, and then we'll move on. Okay, I'm moving on. Okay, data collection. Data is constantly collected. So you take readings, you record, you may be collecting it on the DCS, already recording it for you. You collect samples, you analyze them, you'll also record them. You'll have process control systems to collect and record, which is your DCSs that we've talked about. So what do we use the data for? Sometimes we use it to describe a product or a process. We might summarize this in a report. We might infer what's going on with a product or a process and then draw conclusions about the entire process based on a sample. Maybe we need to predict what could be done to improve a product or process. So that's again what we're looking at here. We would describe the product or process, and then we infer what's going on, see if we're having problems, and then how can we, using this data, make it better. Okay, use data to check process performance. Okay, you can reveal problems with it, right? See how many problems, how many defects you have in one lot. Maybe how large is the problem, right? Analyze it. We do that cause and effect. Prevent the problems using our control charts to keep the process in statistical control. And then confirm corrective measures alleviated by the problem. So after you're done making your fixes, we're going to collect data again and see if any of these are still here. Okay, so let's see some of the data normally process technicians collect. Flow rates and pressures, temperatures. What are some lab techs collecting? Purity, acid, basicity of a particular substance, corrosivity, particle size, specific gravity, viscosity, and others. Okay, now, a lot of times you'll get a product in and you'll get a certificate of analysis. So let's just talk about what it is. The purpose of this letter of analysis or certificate of analysis is to verify that their product specs are met. There's a quality standard. I've talked to you about this many times about ISO 9000. If you get ISO 9000 certified, a lot of times you just go on a COA and you never even have to test the materials because people know, well, you're doing your quality in a really good way. So what is some of the information on the COA? Structure, the name of the particular substance, the formula, its CAS number. Remember, CAS numbers are these by the Chemical Abstract Society. They assign numbers to every chemical, every product, everything made in a chemical realm. They get a number. Any testing guidelines, purity, or other analysis. And then the customers know, right, that they're either meeting it or not. And then who you contact. So let's look at an example of one. So this is from China. Oh boy, I can't believe I didn't see that till now. How about that? Anyway, here we're looking at density and then other types of the products in here, like sodium carbonate and sodium chloride and iron oxides. Colors, particle size, okay, and then the results. So a lot of times you just take this and you have the answer in front of you. So this again, you don't even test it. You may test it randomly, you just do that. That might be part of your process product quality, just the way that you do that. So every once in a while it is a good idea to do it. Now you might not ever test it if your product comes out beautiful all the time, you're getting really high purity, but if your product's starting to have trouble, you might want to test your raw material as a source of a potential problem area. Okay, now we're going to talk about different types of studies. There's enumerative and then analytical. They're both statistical. Enumerative studies focus on the judgment of your results, where analytical, right, you start looking at it, you analyze the information to see if you can improve it. It can be one or the other, but not both. Let's talk a little bit about enumerative studies. They're aimed at a description, begins with random samples from a population, and end with inferences about the entire population. Analytical studies, you're aimed at a prediction, and you begin with evaluation of results and effects, and then end with implicit predictions. Control charts are used a lot in this study. Okay, now we're going to talk a little bit more about data. We're going to go in the little web here. So data definition, fact-finding process, which leads to a final data collection plan. Okay, so you have to say what it is you're actually looking for. Okay, so it's just when you pick your product, you say, okay, your product quality project. I want to like improve the quality of water, right? So that's it. What is the quality of water to begin with, and what is it that you want to improve? So you have to define all these things. Problem statement. So that was my problem statement. Then what's the scope of it? So how large is it, right? Data analysis requirements, the parameters. Then what data? How much data? Right? This is the analysis requirements and parameters. How to collect the data. What analysis is to be done after the data is collected. Then your data collection resources. Okay, so all of these fit together to get into your final piece here. Data collection, analysis, decision, and then your final action. Okay, the problem statement is a clear, concise description of the issues that you have. Okay, it usually includes the process, the time frame, a magnitude of the problem, and then metrics to help you describe that problem, right? Let's go to the next one, the scope of study. Okay, here you formulate a clear statement of the problem addressed with the data. It's narrower than the problem statement because you can't do it. You probably can't always solve everything, right? Ensures the correct data will be collected. So if you do have an area, say you're having a problem with some type of product, do you want to focus on the raw material side? Do you want to focus on the testing side? Do you want to focus on the reaction side? So on. So you have to look at a certain area to start making it better, and then you'll know if your changes are effective because you'll know exactly where you started and you're ending. The statement should identify the specific portion of the process the data will address to help identify the source of the problem and the questions that will be addressed by this data. Operational definition. Now, this is the thing I'm saying to you. This is really important, especially when it comes to your project. It's a statement of the problem or what is required by the customer. A clear, concise, detailed definition of a measure. What to do or observe. It is fundamental when you're collecting any type of data, especially when you're dealing with that attribute data, the qualitative data. The definition of the error must be specified. And there's a method, it's a method of verification. All right, so let's talk about an example. A group of process technicians are studying the nature of injuries within their unit. In order to quantify exactly what they intend to study, they must define the phenomena. So here's how they might define the variable. The number of injuries incurred within the month of 1 month, September 2015. Okay, so that might be one way they decide to define it. The number of injuries incurred within the first 6 months of 2015. Okay, so here, let's take this one. Say you're starting to have a rash of injuries. You're figuring out this month in particular, like, okay, well, we're going to look at this month in particular because maybe something weird happened. And then you could like relate it maybe to an external environment, right? Or something weird like COVID happened, right? And so another whole new set of problems occurred that you weren't expecting because there was something that happened to you. So it helps you define that. But if you're not having too many injuries, but you're having some injuries, you're going to say here, I want to look at the first 6 months and then just see if there's some type of trend. Okay, maybe there's like a lot more in the winter than there are in the summer, right? So that would give you a little trend, and that's how you might be able to find it. Okay, let's go on. All right, so let's do another example. Defines or gives meaning to the variable by describing how it will be measured. Intelligence. So how do you measure intelligence? Boy, that's a tough one, right? Somebody might say height. How do you define your height? Well, that's kind of fairly a little easier. Intelligence, maybe you measure it by a test score on an SAT. Height, maybe it's measured in inches or centimeters. So this is another thing. So if someone just throws out a number for height, you're like, they say it's 76. And you're like, what? What does that mean? Then you're going to have to understand that might be in something like centimeters, although I'm just going over here. But inches, you would have, you know what I mean? You probably say like 8.5 or something. That might make more sense to you, right? But again, you're defining it, and you have to make sure you know. Intelligence. Maybe people know. I scored terrible on SAT. Thank God it didn't measure my intelligence because I would be really stupid. So here's the case where, again, how do you define it? Okay. It's the data analysis requirements. So the type of analysis to be done dictates the types or quantity of the data collected. So this is when you figure out what it is you want, how you define it, then you got to figure out how you want to collect your data to make sure that you're getting exactly the operational definition defined well by the data you're collecting. Then you want to find what the data you're collecting, this will give you the types of graphs, and we've talked about this before. There's attribute data and there's the other data that you use to help. One is qualitative and one is quantitative, so that you're able to do different types of graphs. Say what charts and graphs will be used, what types of statistics and the comparisons, and by what means will you summarize your data. Okay. So parameter. So parameter is a value that tells you something about a population versus simple statistic, which is for a sample. So you have a sample statistic and then a population parameter. Okay, so here it's just an investigator news, and this is what you want to know. Like, you want to take a sample and you're going to infer, right? So we're going to talk about that. Parameters to measure. Collect data on one or more parameters that may be needed rather than on too few. So it's always nice to have a little extra data, right? You may not need it, but then you might also be able to infer other information from that. Who knows? Collect all your relevant parameters. So make sure you do know the ones you have to collect. Consider the cost of collecting certain parameter values, because it can be expensive if you're working in the realm, and if you're doing your project, how much time do you have to do what you need to do? That's also, time is money, so that's important to understand. All right, why is the parameter type important? The type of data, again, collected in the study determine how you analyze it statistically. So, for example, categorical data are commonly summarized using percentages, right? 11% of the students have a tattoo. 2%, 33%, 39%, and 26% of the students in classes are respectively freshmen, sophomores, juniors, and seniors. Does that make sense to you? Here's another example. The measurement data is typically summarized maybe using averages. Average number of siblings students may have are 1.9. Never makes averages, and having number of siblings never makes sense to me, because there's like 1.9 of a person. Anyway, the average weight of a male student, 173. That makes sense. Average weight of a female student, 138 pounds. Okay, so again, what it is you're doing. So your measurement is your observed value equals your true value plus your error. Oftentimes the true value is not known. There's always an error associated with every measurement. Two components are always associated with errors. Okay, remember this: bias or accuracy. Okay, the difference between the true value and the observed value, important in calibration, when you're not sampling correctly, maybe. And then you have your precision. Refers to how repeatable your measurement makes over and over again, right? So is your device precise? Okay, and your measurements are only as precise as whatever it is that you're measuring with. Another key piece of information. Okay, so we've seen this in chemistry, right? This is accurate and precise. You want it in the bullseye, so you got it in the bullseye, and then you are able to keep repeating that over and over again. And these are other ones that are not as precise. Okay, data collection resources. So you can use historical data. So that's something you might do for your project. You should say, oh, I already have old data, and that's fine, because again, we're not doing this for exactly to get a promotion in a job right now. This is for an example of a project. And you can also do planned observations. This is data that you actually set out to do. Okay, so there's methods for collecting data. Observing, you could watch them. Questioning, you can investigate, and then sample also, right? Do a sampling that way, and you can collect the data that way. You could do checklists here, okay? Okay, sorry. So let's talk about sampling. Obtaining data on a subset of a population. It is one of the most common methods that are used all the time. The advantages are reduced cost, takes less time for data collection, and you're more complete and accurate data. It means that you're inferring from a larger population, so you always have a representative sample. So you want to make sure that when you take the sample, it is representative. Okay, so here you want to look at confidence level, making sure the level of probability that the sample would replicate the population is at least 90%. The margin of error, the number of times the sample could represent the whole given on the specific confidence level, and the size of the population. All right, so here's a good point. Document the data accurately. Use analytical mindset. Practice discernment and never falsify data. All right, pay attention to details. Don't be complacent. And then seek clarification when you're unclear. Never falsify data. Okay, it's a serious misconduct and you can lose your job. Very, very important. Okay, so now that's what you had. We collected this data, and this is where we were. So please, if you have any questions, because you're on the home front here, 1 week left. If you haven't done your project, please work on it. If you need help from me, just get with me. I can help you anytime. All right, send me an email. And have a good night. Talk to you later.